Hi everyone, this is Mrs. Heberling. Happy Thursday. Today what we're going to do is take everything we've done this week, so starting with dividing radicals, which we finished up last week a little bit, Pythagorean theorem, and we're just going to review all of it before the end of the week. So today we're going to review these strategies, then tomorrow is going to be our typical Friday Kahoot where you'll get to review it all again. So today you're going to be going through this video using Edpuzzle, and I'm just going to ask some questions through Edpuzzle as we go. So we're going to go through, I believe, 6 examples. And we're going to start with dividing radicals. Now, looking at this, you always want to check, can I simplify either the top or the bottom first? So I have square root 20, which can simplify, but it's just going to be like something root something. It's not a perfect square. Square root of 4, hopefully we recognize right away, is going to be 2. So I'm at the point where I'm at root 20 over 2. So technically I'm in good shape because there's no radical in the bottom. So this is in proper form. But the problem is this square root 20 can still simplify. So it's been a little while since we simplified. So let's take a look at this using a tree. I'm going to do 2 times 10, 2 times 5. And remember, we're looking for pairs. If it has a pair, it can leave the house. So this 2 gets to leave. And this 5 is left by itself. So I have 2 root 5 over 2. Now think about your final answer. 2 root 5 divided by 2 is just root 5. So this crazy this crazy fraction that we had from the beginning, once you use all of your radical rules and your dividing rules, we end up with the square root of 5. All right, next one, another dividing one. So first I want to ask myself, can I simplify anything? 4 doesn't simplify. Square root of 5 doesn't simplify. Is my answer done then? The answer is no, because what is the problem? The problem is this root 5 right here. So try to think, how do we get rid of that? Remember, the way we get rid of a square root on the bottom is we multiply it on the top and on the bottom. The reason we do it on both parts is because this fraction is equal to 1. In math, we can't just multiply and divide and do whatever we want. We have to keep things balanced. So if I only multiply it on the top, I'm changing the value of this fraction. If I do it on the top and the bottom, this only equals 1, so my final answer, my fraction, is going to equal the same thing. It's just going to look a little bit different, like getting a haircut. I'm just changing the way it looks. So when I do that, 4 times root 5 is 4 root 5. Root 5 times root 5 is just 5. So I have 4 root 5 over 5. Do you think this simplifies? The answer is no, because all I could consider is 4 over 5, because those are the whole numbers that aren't inside of a radical. 4 over 5 does not simplify, so my final answer is 4 root 5 over 5. All right, next one. I have 3 over 2 root 5. I wanted to do another example where our denominator has a constant and a coefficient and a radical. So again, ask yourself, can I simplify anything first? That can save us some work. Nothing here is going to simplify, but the problem is this radical in the bottom. So if I wanted to simplify this fraction, I need to get rid of that root 5. I have 2 options. I can multiply by the whole thing, 2 root 5, or if I want to keep my numbers a little smaller, I can just multiply by root 5, which I think is what most of us probably like to do. If you do 2 root 5, you should get the same answer. You'll just have some more simplifying steps. So when I do that, 3 times root 5 is 3 root 5. Remember, a radical and a whole number can't combine. They just kind of get smushed together. 2 root 5 times root 5 is like 2 root 5 times 1 root 5. So 2 times 1 is 2. Root 5 times root 5 is 5. So I get 3 root 5 over 10. And that is my final answer. If you were thinking the 5 and 10 might simplify, they cannot because the 5 is in a square root. The 10 is not. So I'm left with 3 root 5 over 10. All right, now we're getting into the last few topics we've done, which was solving equations that have radicals, and then eventually Pythagorean theorem. So it kind of sets us up for Pythagorean theorem. So if I asked you to solve for x, just like any equation, before we can solve for x, we have to get the term with x by itself. So I'm going to just highlight that x squared. I need to get that by itself. So the first thing I'm going to do is subtract 6. So I get x squared equals 81. And I want x, not x squared. So think, how do I undo this squared? I take the square root. So remember, squaring something and taking the square root are opposite operations. So my answer ends up being x equals, the square root of 81 is 9. And what is that special thing I have to remember when I take the square root? It's that the answer is plus or minus, because negative 9 times negative 9 is positive 81, or positive 9 times positive 9 is positive 81. So get that x squared by itself first, always, and then use that square root to figure out what x is. All right, last thing we're looking at is 2 Pythagorean theorem examples. So a few reminders. Pythagorean theorem is a squared plus b squared equals c squared, where a, b, and c all represent sides of that triangle. The most important side we have to worry about is c. C is always the what? C always has to be the hypotenuse. In this case, think about what the hypotenuse would be, because the way this triangle's turned makes it a little bit tricky. Which side do you think is the hypotenuse? If you're thinking it's x, you're correct. It's across from the 90. It's the long side that's not touching that 90. So this is my c, or my hypotenuse. So I'm just going to put my x squared in there, or you can keep a c. That means that the 9s are my a and my b, but they're interchangeable and they're the same number. So I can just do 9 squared plus 9 squared. I can use my calculator from here or simplify a little bit further. When I take 9 squared plus 9 squared, that's 81 plus 81 equals x squared. Gotta get my calculator out here. 81 plus 81 will give me 162 equals x squared. And then what do I do to get my final answer? Again, I'm left with that x squared. I need to take the square root. So I take the square root of 162, and I get 12.7 feet for my answer. And we'll just stick to 1 decimal place for these answers. All right, last one. One more Pythagorean theorem. It's going to work the same way. Just want you to get a little bit more practice with this. This is something you'll see in the future in geometry especially. So if I look at this, I first have to identify which is my c, which is my hypotenuse. Across from the 90, the long slanted side, which side do you think is the hypotenuse? If you said 8, you are correct. This is my c, so I'm going to put 8 squared in there. That tells me then that my a and my b are x and 4, and again, those are interchangeable. So I'm just going to do x squared plus 4 squared, but you could also switch those because of the commutative property, if you remember way back to chapter 2. And now I need to solve for x. So remember, I need to get this by itself first. How do I do that? I need to subtract whatever this number is. So if you want to go right to your calculator, you can. If you want to take one more simplifying step to make it look like this, you can do that. But now if I want this by itself, I need to subtract 16. So I get x squared equals 48. And I can take the square root of 48. And I get an answer when I round to 6.9 feet. And that is it. So like I said, tomorrow our last COE of the week is going to be our typical Friday Kahoot, and it's going to be these same exact types of questions. So if it helps you as you're doing the Kahoot, you can watch this video first, you can refer back to it, you can write these examples down. Just take your time. I know it's easy on the Kahoots to want to guess because it's multiple choice, but try to give yourself the best opportunity to get it right so we can really, really see what you know and you can see what you know.